Another 3 examples for adding and subtracting radicals. Example 4. Say we have 5 rad 12 plus 9 rad 2 minus 5 rad 8 plus 6 rad 27. At first glance, the 4 radicals have different values, so it's like having 4 different variables. However, we notice that each of the radicals can be broken down. Now, I'm going to start to go a little bit quicker here. When we look at rad 12, I recognize as 12 being 4 times 3, but 4 is 2 squared. So I'm going to write this as 5, 2 squared 3. If I'm confusing you with that step, just go off to the side and do your prime factorization. You'll see that it breaks down as 2, 2, 3. With the 9 rad 2, that's not going to change at all, so I'll just rewrite it because 2 doesn't break down. With 8, 8 is 4 times 2, which could be 2 squared 2 under the radical. And 27 we've done a number of times now. You should recognize that as 3 squared 3. So I have these listed as partial squares. I'm going to bring out the square component. Recall that when it comes out of the radical, it loses its exponent, and it comes out with multiplication. So this becomes 5 times 2, which is 10, radical 3. Second term does not change. Third term, the 2 can come out. 2 times negative 5 would be negative 10, radical 2. And this last term, I bring the 3 out. 3 times 6 is 18, radical 3. At this point, I look for like variables or like critters. So I notice that the first and last terms have the same label. They each have a rad 3, so I would be permitted to add or subtract their coefficients. 10 plus 18 would be 28, radical 3. As I look at the 2 inner terms, the 2 middle terms, they have the radical 2's, so they're like terms. I would be permitted to add or subtract the coefficients. 9 take away 10 would be negative 1, radical 2. Now if you want to put your 1 there, you can. Not having it, it's kind of implied. And I know I have to stop here because this is as different as an x and a y. This is like 28x minus y. That would be your final answer. It's a binomial. Let's do an example 5. We'll just keep on rolling. With example 5, be very much like example 4. We'll go 3 rad 75 plus 2 rad 24 plus 4 rad 12 minus 4 rad 150. Now, as I said, in these examples I'm going to go a little bit quicker. The 75 I recognize as 3 quarters. So 3 times 25, but 25 is 5 squared. So I'll go 3, 5 squared times 3. The 24 we did in a previous example, that's 4 times 6, where 6 is 2 times 3. Neither component could get out of the radical, but the 4 I could write as 2 squared. So that's 4 times 6 is 24, where the 6 is a 2 and a 3, but neither part would be able to get out of the radical, so I went ahead and multiplied it together. When I go to 12, 4 times 3, in fact, I used that in the last example. It would be 2 squared 3. So I can say this would be 4. Under the radical, I've got 2 squared 3. And for the 150, I'm thinking of 6 quarters. 6 quarters is $1.50. So I could do a 6 and a 5 squared. Now let each of the squares come out of their radicals. And so this becomes 15. The 5 times 3 is 15, radical 3. The 2 comes out, would be 4, radical 6. The 2 comes out, would be 8, radical 3. If 5 comes out, it would be negative 20 rad 6. At this step, I'm looking for any like radicals, like critters. So I notice that my rad 3's are the same. I can take 15 plus 8, which would be 23 radical 3's. And then I look at these radical 6's. 4 take away 20 would be negative 16 radical 6. And there's your example 5. I know to stop because those radicals are different values, different labels. And we'll do one more example here. I think I'm going to grab another piece of paper. I'm going to box myself in there. So we'll call this example 6. And with example 6, we have 9 rad 20 minus 4 rad 8 plus 7 rad 5 plus 7 rad 18. Hopefully you're starting to get the trend here, understand what's going on. We look at the radicals, we see they're all different, so I can't add or subtract them. However, I have a sneaky suspicion that several of these can be broken down. So the 20 is 4 times 5, which could be 2 squared 5 under a radical. 2 squared 5. 8 we've done a number of times now. We know that 8 is 2 squared 2. Why I do not write that as a cube is because the index is a 2. It's a square root. I'm only interested in square values. Plus 7 rad 5. 5 doesn't break down. 18. I don't think we've seen that one yet. 18 is 9 times 2, but 9 is really a 3 squared. So I can say 3 squared 2. And then I look to bring these partial squares out. As I bring these squares out, 2 times 9 becomes an 18 radical 5. 2 times 4 becomes a negative 8 rad 2. Third term does not change. Fourth term, I could bring the 3 out. 3 times 7 is 21 rad 2. And now I'm looking to add and subtract like labels, like critters. I see that these radical 5's are the same critter, the same label. So 18 plus 7 would be 25 radical 5's. That permits me to add those coefficients. Next, I see that these rad 2's are like. These like terms could be added or subtracted. So 21 take away 8 would be 13 radical 2's. And I get to this point where my radicals are different. I stop at that point. I have 2 terms for my final example. Now you have 6 examples to go off of. Hopefully that helps you out with this idea of adding and subtracting radicals.